In this video, I'll introduce you to the idea of integrating using the method of substitution, which you'll see is a very, very useful tool. The idea here is that we're going to try to reverse the chain rule. So recall that if you're taking the derivative of function composition, so f of g of x, one more, that we take f prime of g of x times g of x, g prime of x. Okay, so if we were integrating something that looked like the derivative of a function composed with another function, where the derivative of that inner function shows up on the outside, right? So we have some inner function here and its derivative, which is showing up over here, then we would get f of g of x, right? This was the original function. This is its derivative. Okay, so if I integrate this piece, I'll get back over here, plus c, of course. Okay, so let's see an example. Let's say I am integrating the function x squared plus 7x minus 3 to the 5th power times 2x plus 7. So notice that the derivative here shows up over here. So for substitution, we usually call this function u, and then this would be the derivative of that. So this would be u prime. Okay, and of course for integrating, we also need our dx. Tells us what we're integrating with respect to. So in this case, if we were to take x squared plus 7x minus 3, apply the power rule here, so we get this to the 6th power over 6 plus c. You might be asking, well, what do you do with the 2x plus 7? But remember that when we take the derivative over here, we have to use the chain rule. So, reversing the process, if we were to take the derivative of this function, x squared plus 7x minus 3 to the 6th over 6 plus c, if you were to take the derivative of that, let's see, we would get 6 x squared plus 7x minus 3 to the 5th over 6. And then we would multiply by the derivative of the interior function, 2x plus 7. The 6's cancel, and what we're left with is we're left with the original function that we were trying to integrate, that we were trying to find the antiderivative. Okay, so taking the derivative over here, right, taking the derivative, we get this, which was this original function. So that shows that when I integrate it, I should get this function. Okay, so we just happen to notice that the derivative here shows up over here. But more formally, how would we do this? Well, we might see that the most complicated part of this whole function is this thing we have that's being raised to a 5th power, okay? So how I would solve this if I were given this problem originally is I would write u equals x squared plus 7x minus 3. That's going to be my substitution, or what we might call change of variables. And then I would think du, okay, kind of like doing differentials, right? Du is 2x plus 7 dx. So when I go back up here, let me highlight this in pink. This whole part I can replace with like that whole part in pink is showing up down here. So I can replace it with du. Okay. So this integral, the original integral up here, is equal to u to the 5th power times du. So u to the 5th power times du, now I can use the power rule and say that's u to the 6th over 6 plus c. And what I want to do at the end is I want to plug x back in because I don't know what u is. You know, u depends on what we're plugging in. So I want to replace it, get back to x. So now I have x squared plus 7x minus 3 to the 6th over 6 plus c. And we see that that's the same answer that I was guessing at up here. Okay, just by noticing that this is u and this is u prime. So down here, what I've walked you through here is the process you would go about doing this for any old integral.